This gearbox has a gear ratio of 1 to 512, which means if we could rotate the handle, the small gear will spin extremely fast. I'm incorporating some of the design decisions that I used in my gearbox generator project. I'm not using herringbone gears for this project, but I am using very beefy gears towards the input side of the gearbox. And also, instead of hot gluing the gearbox stand to the table, which I've had varying degrees of success with, I added a bunch of mounting holes to the gearbox stand. There should be no issues with the gearbox coming off of the table. Another thing that tends to be problematic with these gearboxes is the attachment of the handle to the shaft. So I'm not messing around with this project. I'm going straight to the strongest thing I could find, JB Weld. It supposedly creates a bond that is stronger than steel. I'll show you what I mean when I say I'm putting the beefy gears towards the input side of the gearbox. The first gear that will attach to the handle is actually solid PLA, and it's the thickest gear. The next gear is also solid and is slightly less thick. Gear number 3 has 50% infill and is slightly thinner. We continue through each gear getting progressively thinner, smaller, and lighter until we reach the last gear, which is the smallest, thinnest, and weakest gear of the system. This is the gear that's going to go the fastest. The first gear is the drive gear, and I'm epoxying it to the shaft. It is critical that this epoxy holds. I'm applying the epoxy to the shaft and I'm sandwiching 2 washers on the outside of the gear. This should really hold it in place. And now it's time to attach the remaining gears. A lot of you suggest starting with the smaller gear and slowly working my way up the system, kind of like how a car shifts gears as you go faster and faster. This does help a little bit, but you do get to a point where it becomes very difficult to spin the biggest gear. Even with 2 hands, it's still extremely difficult to spin the gearbox any faster. Already it's spinning pretty fast, but let's try it with the handle. Now you may be thinking to yourself, what's with the tiny handle? Shouldn't you be using a giant handle to really make it spin fast? You're 100% right, this gearbox does need a much bigger handle. The only issue is I mounted the gearbox to the center of my table, but it shouldn't be too much of an issue besides the fact that I epoxied the gears onto the shaft, which means it's going to be very difficult to access the screws underneath the gears. I finally got the gearbox off of the table, and by that time the large handle had finally finished printing. I designed it in a way that allows it to be mounted right on top of the old handle. So I managed to break the JB Weld connection from the handle to the axle shaft. But I have a feeling the previous gearbox speed record has been broken. My previous record was about 9,000 RPM. If we roll back the footage, we can see that I did half a rotation in 1.5 seconds, which means a full rotation in 3 seconds. And if the gear ratio is 1 to 512, that means it's about 10,000